Good morning. I can't hear from backside. Good morning. Yeah. My name is Dhanush. I'm an HF application engineer at Entuple Technologies, Bangalore. Okay. Today we are here for EMI EMC. Okay. Just I give a brief introduction about what Entuple does and what are the products and what are the domains we work in Entuple. And we are tied up with Ansys, and we are using that product for simulation purpose. Okay, and we have so many domains in our Entuple. I'll just brief out the domains, and our teammate will explain today's session. Okay, I'll take just 30 minutes to explain our about Entuple technologies and Ansys. Okay, yeah. This is a small vision and mission of our Entuple technologies. We are a holistic solution enabler for academia and research and like aerospace, defense. These sectors we are providing solutions. This is our visions, and our mission is coming to provide a best and possible solution for the upcoming sessions, like for 5G or 6G. For that we are providing solutions. This is our mission, and I'll just give a quick overview of our Entuple technologies. We are young and growing company in a market. We are just 14 years young. Okay, and we have 130 plus team members all over India, and we have 150 corporate customers like Benz, Porsche, different corporate customers we have, and 750 colleges. We will touch all tier 1 to tier 3 colleges like IITs, NITs, triple ITs, and tier 3 colleges also. And under our training arm Abhyanta, we trained 5,000 plus students, research scholars, engineers. That's we provide an internship for the students. Different domains we are providing with students or research scholars or PhD holders. Like we are providing internship for them, and we have 12 offices in the major cities. These are the cities we are listed below, and we have our head offices in Bangalore. Okay, and these are the markets we mainly look: aerospace, defense, public sector, research lab, and academia and engineering. Okay. And this is a small globally recognitions we get from the different companies. We are the partner for Cadence also. Anybody work Cadence here? Knows Cadence, right? Yeah. And we get appreciation from Ansys also, and we get best simulation from APAC. APAC is nothing but Asia's best solution provider. At top 20 we are getting award from them. Okay, these are the small recognition we get for Entuple technologies. And these are the domains where we are specializing. Coming to the mechanical, CFD, EMAG systems and semiconductor, these are the Ansys products. Coming to mechanical, we are using for CFD analysis, okay, and structural analysis, thermal analysis. We are using mechanical tool, CFD, fluid analysis. Okay, coming to EMAG, using for EMI, EMC, antenna fabricating and heat exchange. For that purpose we are using EMAG. And system, it's an embedded software tool. And semiconductor, we are using Power Artist, Red Dot. These tools are available for a semiconductor, and we are partner for Cadence also. We are using Cadence tool for this semiconductor. And industrial design, we coming to the ARCAD, and we have our own product. And augmented reality, PTC. PTC is a AR/VR tool. We are partner with them also. And coming to the industrial IoT and IoT, that's our OEM product. Actually, we provide a kit for colleges. It's a true IoT kits. We only provide for different colleges. That's our own kit. Okay. And coming to the power electronics, for measuring the power and signal integrity, power integrity, we have our own product called Wavect. That's our OEM product. We are the partner for that also. And VNA. Tomorrow I think we have a session from Heinrich. Okay, we are using for that measurement, antenna measurement. We are using for VNA, vector network analyzer. And coming to the RF solution, RF solution is nothing but anechoic chamber. Heard about anechoic chamber? Yeah, you have. Okay, I don't know about that. For testing the antenna, how it will be radiating and all. And AML, we are using Ansys product. And PCB prototype, we have a MITS machine. And Bungod also, we are partner with them. And coming to the additive manufacturing, you heard about EOS for 3D printing. It's a 3D printing tool. We are using we are also partner for EOS also. These are the domains where Entuple works. Okay. And we have two offices in Bangalore itself. One is head offices and one is registered office. In that we have a different products, but Ansys is common in that. Coming to the CAE business unit, that is much focused on aerospace and defense. Okay, they work with Nano Atoms, MathWorks, Xilinx, Adobe, and Easy business unit, that is much focused on academia thing. Provide the solution for research scholars, and some faculties are working for DRDO projects like ISRO projects. For that we are helping in the Easy business unit. We are partner with Cadence, OrCAD, Anritsu, PTC. I already mentioned about Abhyanta. Abhyanta is our training arm. There we provide internships. We have paid internships. Okay, provide for the students, like we have customized agenda also. Based on your agenda only we can provide the training for you guys. For example, you have a requirement in antenna domain, you have specific antenna, we can provide this internship for you based on your requirement under Abhyanta. Okay, and True IoT is our OEM product, like that is providing kits like Raspberry Pi, Arduino kits. We are providing with the True IoT kits. And Bungad, it's 3D, like for fabrication, antenna fabrication. We have chemical etching, and you heard about chemical etching, right? For antenna fabrication, chemical etching, for that we are using Bungad. Okay, now we have a MITS machine. It's like Autolab and 11 Lab, both machines are available. I'll give introduction on next slides. Okay, and MITS and EOS for like EOS for 3D printing. Okay, these are the our office, about Entuple office. And we follow core values. These are the 5 core values we follow everywhere in Entuple Technologies: integrity, excellence, agile and responsive, united and focus, and social and environmental responsible. Okay, these are the core values we follow in Entuple Technologies. And coming to the electronics product design flow, earlier, before coming simulation tools, these are the product design flow we are following. First we have a product specification with us. We go to the designer. For example, I need to fabricate one microstrip patch antenna. I have a dielectric constant, thickness, material, everything. I go to the designer. I told him to design this microstrip patch antenna. These are the product specification I have. I give that product specification to the designer. He will design and he will fabricate. After only we can test that. It's not match our requirement. For example, I want return loss at 2.4 gigahertz. It will be resonating at 3 gigahertz. Then it's no use. Okay, then I'll go back to the designer. He need to rework the design and he should start again the fabrication. That's the issue. Nowadays, we are added simulation tools. For example, I have a product specification. I give to the designer. Designer have a simulation tool. For example, Ansys and any other tools. He will simulate microstrip patch antenna there itself. Once it will match the requirement, for example, a return loss will match, you will go for the fabrication. Then test and verification, then go for the production. Then we save a time, short time design, and like it's a cheaper process. Coming to the cost wise, earlier we need to fabricate. Once it will not match our requirement, we go back to the designer again, he will fabricate again. That's take a too much time and it will cost effective also. So we are using this simulation tool for use less time and cheaper process also, and it's a first pass design success only. Okay, that's why simulation tools are very important nowadays. Okay, and coming to the Entuple solutions, we have entire solution for antenna domain, antenna solutions. For example, coming to the simulation, we have Ansys HFSS, like electronic desktop tool. Include that there is so many bundles include that. I'll show the bundles what are included. Coming to the fabrication, we have MITS, okay, for fabrication. And coming to the VNA, we have partner with Heinrich also for testing. These are the complete solution what we provide from Entuple Technologies. And this slide is about Ansys. We are partner with Ansys, okay, and Ansys is setting a gold standard accuracy all over our Indian market and global market also, and it's globally 6,000 plus full-time employments are there in Ansys, and it's proven revenue in 2022. They are not disclosed 2023 and 2024. It's in they are not disclosed yet. This is a proven revenue on 2022, and we much focused on the simulations, and these are the committed states. 93% of customers will agree that Ansys is a gold standard tool. Okay, and we are setting a gold standard in all comprehensive simulation suites. We have for entire engineering solutions for different domains, coming to the mechanical, civil, or electronics, telecommunication. We have all solution for in Ansys, and coming to the simulation accuracy, you can check in like DRDO, ISRO, anything. They are tell that Ansys is best compared to other tools, because we maintain that gold standard all over in the market. Okay, and we have expert engineering partners like Entuple, and different partners are there, and we have an open ecosystem in Entuple also, in Ansys. Why? Because they provide virtual classes. You can go to the campus of Ansys, otherwise you can sit in virtual, you can attend the training itself. Okay, that it's a free, they're providing that. And coming to the electronics bundle, once you open Ansys electronic desktop, these are the bundles it's available. Okay, coming to the HFSS, HFSS is nothing but high frequency structure simulator. Okay, that is used for 3D simulations. For example, you want to design an antenna or filters, couplers. For that purpose, we are using Ansys HFSS, and you can use for high frequency applications. And coming to the Maxwell, Maxwell is a low frequency application. There you can design a motors, transformers, like battery management system. You can do in a Maxwell application. That's a low frequency application. Okay, and coming to the SA wave. SA wave is a signal integrity and power integrity tool. There you can check your PCB, it's working fine or not, whether its circuits is working, and if you want to check that shortings, for that purpose you can use this SA wave. Okay, next coming to the IcePack, that is a thermal simulator. For example, IC designing any PCBs, if you want to check the thermal heat exchange, for that purpose you can use this IcePack, and you can check the deformation also, how it will be deformed. For example, we give a much more heat to the PCB, how it will be deformed. For that purpose we can use this IcePack also. And coming to the Q3D extractor, Q3D extractor is evaluation of RLC circuits. In a PCB you can extract RLC circuits. For that purpose we are using Q3D extractor. And coming to the MotorCAD, that is specially for motors. Okay, if you want to check windings in a motor, for that purpose you can use MotorCAD. And Sherlock, if you want to predict a component duration or working process, how it will be working and what is the duration for that and what is the durability, you can check in Sherlock. For that purpose we are using Sherlock, Ansys Sherlock. And EMA 3D cable, that is for check a cable harness. Okay, in 3D cables we are checking cable harness. For that purpose we are using this EMA 3D cable. Okay, this is a bundle in electronic desktop. Anybody have any doubts in this bundle? Sorry. Sorry. Any doubts? No? Okay. And coming to this is a chart. We are there in every multi-physics also. Okay, coming to the industries, we are aerospace, defense, automotives, engineers, and healthcare, high tech. For that we have entire solutions. Coming to the physics based simulations, structures and fluids, electronics, photonics, optics, numerical. We have different tools, depends on the physics. Okay, this is a capability chart of Ansys. Okay. Next, we are directly coming to the Ansys HFSS. HFSS is high frequency system simulator tool, it's used for 3D simulations. Okay, we bridge a gap between industry and like academia. We are maintaining a same standard in academia also. Why? Because like that placements are required simulation tools nowadays. So many opportunities are there in wireless communication sector. Okay, and in that HFSS we can extract S, Y, Z parameters, scattering parameters, and near field, far field. Okay, for that purpose we are using this HFSS, and we have 5 major solvers. This is very important solvers in Ansys HFSS. Coming to the first one, FEM solver, finite element method solver. Anybody heard about FEM solvers? FEM solvers? Okay. That FEM is a finite element method solver. That size of lambda is 10 lambda. Up to 10 lambda you can design in FEM solvers. Okay, that's a default solver in Ansys HFSS. For example, you are designing any antennas or RF structures, PCB structures up to a 10 lambda, you can use this FEM solver. Okay, and compared to other solver it will take less time. Okay, why? Because lambda size is less and it will mesh fast. So most of the antenna designers use these solvers. Why? Because it solves fast and give accurate results up to a 10 lambda, not more than 10 lambda. Okay, if you want to design more than 10 lambda, you can go with IE solver, that is integral equation solver. It's work on based on MOM. Okay, methods of movement it works on, and the lambda size of that is up to 100 lambda it will work. Okay, and for example, when we use this IE solver, you can, when you are using automobile application, you are designing any automobiles application and ships or aircraft antennas, that purpose you can use this IE solver. Okay, next coming to that shooting and bouncing ray, that is SBR plus solver. Okay, you can use for RCS simulation, any you are designing any ADAS vehicle simulation, for that purpose you can use this. Or light straightening, you can simulate that light straightening from aeroplane or helicopter, for that purpose you can use this SBR solver. Or you are designing any human phantom, that purpose you can use this solver, and the lambda size is 1000 lambda, up to 1000 lambda you can design. Okay, these are the 3 solvers. And coming to the physical optics solver, this is a solver solve 1000 lambda to 10,000 lambda. Okay, it will take too much time to solve. Why? Because this is an optics solver. It's solved like using for any light straightening, or if you want to see the RCS or phased arrays, that time you can go with the physical optics solvers. Okay, and the applications and examples are same compared to the SBR plus. After 1000 lambda you can design, you can use this physical optics solvers. Okay, you can select by manually that it's available, option is available in Ansys HFSS solution type. In that solution type you can choose this solvers. Okay, and coming to the transient solver, it's a time domain solver. If you want to design any time domain application, that time you can use this transient solver. It's nothing but eigen mode solver. Okay, this is a different solvers what we are working in, and this is our core strength. Okay, adaptive meshing. In Ansys HFSS, no need to make a mesh. It will defaultly making a mesh. It's a tetrahedral mesh. Okay, why mesh is important means it will subdivided a structure in a tetrahedral shape and it will give a accurate result. That purpose meshing is very important. Okay, this is our strength. It will not affect fringing field. Okay, anybody works in HFSS here? Nobody? Only 1, 2. Okay. And we have a material libraries. Here you can add your own materials. There are so many 500 plus materials are available, like Rogers or FR4, air, vacuum, gold. There is plenty of materials are available here. If you have your own material, you know bulk conductivity, dielectric loss, then you can add your own material. You can rename it based on your wishes. and you can simulate. You can use this material and you can simulate. This option also available. Sorry. And these are the main results you can extract from Ansys HFSS. Return loss and 3D gain plots and 2D gain plots, Smith chart. You can integrate with circuits and you can check the impedance matching also. That option also available in Ansys HFSS. You can dynamically link with any tools. Coming to the multiphysics, for example, I'll design like what is that diplexer. For example, for that I can give a input. Okay, I can design in Ansys HFSS and I can pass through a space climb or workbench. I can measure, I can give the heat, how it will be respond and how it will be deform. For that purpose we can use Ansys mechanical also. I can check the deformation, how our diplexer will deform once we'll give this much of current or anything for that diplexers. I can use the for multiphysics also. You can dynamically link with any Ansys products. Okay. And this is antenna toolkits available. Okay, it's already available in electronic desktop. There is so many antenna types are available, and coming to the any examples, different domains. Coming to the motors, there is so many available designs are there. For example, in coming to the antenna domain, planar dipole antenna is there, rectangular patch is there, and bow tie antennas are there. So many antennas are there, so many examples are there. You can check, you can save your time also. Just assign the frequency and you can check the results, how it will be work. For that purpose you can use this antenna toolkit. For you are designing any phased arrays, coming to the 4x4 arrays or like 100x100 array, or you are doing any passive and active elements antennas. For that purpose you can use this HFSS also. And if you are designing any layouts, for that purpose you can use Ansys HFSS 3D layout also. Okay. And coming to the HF electronics or ubiquitous is nothing but we are everywhere. Coming to the semiconductors, we are there in power ICs, discretes, filters, manufacturing. We are there in that semiconductor domain also. Coming to the automotives, EV, hybrid, ADAS vehicles. For that purpose we are using SBR plus solvers. Okay, that also you can use. And coming to the wireless, you can design antennas or ultra wideband antennas. You can design any antennas in that Ansys HFSS, and you can design filters also. And coming to the aerospace defense, for that purpose also you can use Ansys HFSS to check like aeroplane CUSAT, how it will be like 6 antenna parallelly, how it will be working. For that purpose also you can use this Ansys HFSS. And you are coming to the mobile communication. In mobile you have 6 antennas, how it will be work for like Bluetooth antenna, Wi-Fi antenna, how it will be radiating, how it will be working. For that purpose also you can use Ansys HFSS. And if you can import a human phantom also, you can check SAR ratings, specific absorption rate. You heard about specific absorption rate? For that purpose also you can use Ansys HFSS. For example, you can do a human phantom, and you can place an antenna near a 2 mm of ear or eye, and how it will be effect for your human body. For that analysis also you can use Ansys HFSS. Okay. Coming to the Maxwell, it's a low frequency application. You can design like power management, battery power management. For that purpose you can use this Maxwells or transformers or like motors. For that purpose you can use this Maxwell application. And these are the applications what we are working in Maxwell's. Coming to the battery management and wireless charging simulations also. This simulation is completely based on wireless charging. Nowadays wireless charging or much booming for watches or phones. For that analysis also we can use this Maxwell's application. Okay, these are the Maxwell application what we are working. Okay. Coming to the designer, designer is nothing but circuits. You can see in electronic desktop it's rename it as circuits. Now not in a designer, rename it as circuits. Okay, there you can do a circuit simulation. Just drag and drop the circuits, and you can design any piezoelectric sensors, different sensors, or any structures you can design with the circuits. Okay, and system simulators also, and planar EM. Coming to the Smith tool, there you can do an antenna impedance matching also. For network matching you can use this designer. Okay, and this is a small GUI how look like and Ansys designer. These are the circuits we can design in Ansys designer. Just drag and drop the components. Okay, it's very easy and it's user friendly tool. Okay, and coming to the circuit simulator, these are the components available in circuit simulator. BJTs, capacitors, coaxial cables, different components are available. Just drag and drop and you can utilize this designer. And this is a system simulator. Here you can see this different results coming to the transient plot, high diagram, and different results you can extract from this designer tool. Okay, and coming to that planar EM, these are the results you can extract from planar EM. For example, if you want to see results on top of your antenna only, you can visualize that radiation plot on top of your antenna itself. Okay, and this is a Smith tool. You can you can connect your circuit to an antenna and you can check that how it will be network matching or impedance matching for your antenna. For example, for that purpose also you can use this designer. Just dynamically drag and drop your antenna from Ansys HFSS to the circuits. You can connect a different ports. Okay, it automatically calculate the port 1 and port 2 values and give the results. Okay, and you can dynamically link with Q3D extractor for evaluation of RLC circuits, SA wave and HFSS also. You can dynamically link with SPICE, IBS model, transient plots also. For this, you have these kind of files you can import and you can do the designs. Okay, if you cadence also supported for Ansys. For cadence you designing any circuit boards, you can import to the Ansys and you can check the results also. For that purpose you can utilize Ansys. Okay, and Q3D is evaluation of RLC circuits. You can use the calculator to calculate the different values. How for example in a PCB board, for example, if you want to calculate the resistor value, you can use this Q3D extractor, and this is a small GUI how it will be look. Okay, sorry, I'm a bit rushing. Why? Because another session is there. We are running out of time, that's why I'm be rushing. Okay, sorry. And coming to the SA wave, there you can check power integrity and signal integrity of PCBs. Okay, here also you can extract SYZ parameters and near field, far field of your antennas placed on a PCB boards. Okay, you can simulate. For example, you place your antenna in a PCB boards and that PCB board how it will be working and how much heat will be transferred. For that purpose also you can use SA wave. You can check a near field also how much it will be radiating, antenna radiating on the PCBs. You can use this SA wave. And these are the application. These are the less application I placed in slides. There is more applications available in a market. Okay, coming to the PCB board modeling and simulation, for that purpose also we are using SA wave. And coming to the EMI EMC, today's session is completely focused on EMI EMC. Okay, our colleague will take that EMI EMC through virtual. Okay, and these are the applications we can see in SA wave. And this is a small GUI how it will be look. SA wave, this is a GUI of SA wave. Okay, and in that SA wave we have a electrical property calculator. You can calculate a simple circuit values also using this SA wave. You can in the board you can calculate any properties, electrical properties in a PCB boards. That option also available in SA wave. And in Ansys we are maintaining this accuracy, capacity and speed. We are maintaining these values only, core values only. We can give a gold standard simulation tool accuracy in a market. Okay, And coming to the MITS prototyping machine fabrication, these are two machines available in the market. One is 11 lab and another one is auto lab. In 11 lab you can change the bits manually. In auto lab no need to change the bits, automatically it will change based on your antenna design or any circuit design. Okay, these are the two prototyping machines available from MITS. And these are the small designs what we are designing in fabricating in MITS machine. Okay, these are the fabricated design. And coming to the VNA is nothing but a vector network analyzer. We are partnered with Ansys also, Heinrich. We are for testing and measurement. Okay, and I'll coming to the conclusion. These are the areas we currently working. Coming to the aerospace defense, medical systems and automotive systems, and semiconductor and IC packing and telecommunication. These are the domains we are working. Currently we are working. Okay, if you have any doubts related Ansys electronic bundle, you can let you know after this session finished. Okay, I'll be sharing my contact and email address. If you have any queries related to the electronics domain or RF circuit or wireless communication, you can mail me. I'll get back to you on that. Okay, and thank you. Now the another session will be take place. Anybody have any doubts related to the bundle? If you have any doubts, please let me know. Yeah. Okay. CSTS.
Can you tell what are the advantages of CST or HFSS and drawbacks?
Yeah. We are not talk about a CST. Just I'll just mention competitor. I'm not mentioning any like tool name. Okay. First I'll mention the advantages of Ansys. In other competitor you cannot do a human phantom simulation. You can do, but it will not accurate result. Coming to if you want to do any SAR analysis, coming to HFSS only, you get accurate results comparing to the other competitors. And coming to different antennas, there are plenty of materials are not available in different competitor tools. That's why we are telling HFSS is best. If you are facing any issues with HFSS, like which tool you are using simulation tool?
I'm using CST only.
CST. You are comfortable with CST?
Yes.
You didn't use HFSS?
I have studied, but doing on CST.
Oh, you are facing complications in HFSS?
No, basically we were doing in CST. That's why.
Yeah, CST. I agree with CST. It's a good, but why not HFSS? That's what my question is. Both are simple. Both are available. Free versions also available in Ansys. Why not Ansys HFSS? You are facing any difficulties or accuracy issues?
Not because of accuracy issues and all. We started studying in CSTs.
Okay.
So we based on that. That's only.
Yeah. Once you use Ansys HFSS, free versions are available. I'll show the free versions also. You can install HFSS and you can work with HFSS. It's very user friendly. Okay, it's not too much complications. In CST you can like just for metamaterial or any different components you need to select a material or a structure, it automatically creates. Here you need to draw manually. That's why people are facing difficulties in Ansys HFSS. But coming to the accuracy wise, nobody can beat us. Okay, that's what I'm telling. It's compared to other competitors, it's very user friendly and very accurate. That's what you once use HFSS. Student version is available. You can install and you can use Ansys HFSS. And one more thing, we have a free courses, Ansys innovation course. Ansys innovation course. Here we have up to 500 plus courses are available. It's a free. If you are working on a different domains, we have coming. If you are working in structure, optics, numerical or electronics, motors, See, there is different categories are available here. You can select any categories coming to the electronics or materials. Python also it's available. Coming to electronics, 148 cores are available. Okay, just you can select any electronics related course. You can enroll and you can get a badges also. It's a free of cost. You can utilize this Ansys innovation course and you can enhance your knowledge also. It's a free, completely free for everybody. Okay, and one more paid versions are available. It's if you want any certifications from Ansys, you can use this Ansys Learning Hub. It's a paid, okay, it's a paid version. You can pay some amounts and you can get a certificates from Ansys Learning Hub. Ansys Innovation Course and Ansys Learning Hub. Learning Hub is paid, Innovation Course is free. Okay, you can utilize this Ansys Innovation Course and you can get Ansys GPT. If you are facing any doubts related to any electronics or any different doubts, you can just enter here related to your antenna doubts or filters or any different doubts. Just like it's like similar to ChatGPT only, it's related to only Ansys. Any different structures or designs, you can use this GPT and you can get the results, and it will give the reference also, reference papers or reference designs. You can use this GPT. It's a free. Once you need to enroll this, okay, just log in here and you can get access for everything. Okay, and any doubts? Yes, we have a designer. Yes, we have different formats, like coming to the cadence. If you want to extract from cadence, Allegro.
Import components from analog devices like PLL or something like that.
Yes, you can import to the circuits and you can do the simulations.
Whether in the Ansys library those components are available?
Which components?
Like PLL or demodulator.
Modulator, that all are available.
The ADCs.
Yes, that all are available.
All available.
Yes. But you need to procure a licensed version for that. Free version, it's difficult. Its limitations are there in free versions. Once your campus procuring this licensed version, then you can use this components. It's available in libraries. Okay, and you can dynamically link with any other different tools also. So you can import a cadence file or different files you can import.
So after designing, we can directly go for the PCB manufacturer.
The boards also available in SFA. Once you much good in power electronics or PISI, for that purpose you can go for SAV and you can integrate with board and you can check the results also. How it will be shorting, VSD shorting or VSS shorting, you can identify through the SAV.
Yeah, that is once you design Allegro, then you can import it and you can check, right? But whatever we are doing in
Allegro, there are so many formats. I'm not talking about Allegro. That's an example. There is so many formats available like SIP format, EMCM formats, and different formats are available. So many Gerber also you can import.
Okay.
Options are available. Any doubts?
Can we import structures inside in other simulation tool like CST to HFSS and run it in?
Yeah, what's the format of CST? File format? CST file format. For example, you are designing any format in CST. What is the format in that? File format. It should be in in coming to the electronics Ansys. It should be in AEDT format. Like that in CST there is a different formats. You tell that format? I'll check whether you can import or not. .cst it's difficult. You can convert that file to any other file format. You can import that. There's so many converter are there in Ansys, free converters. You can put your CST file and convert to any ADT format and any different format. You can import to the Ansys and you can check the results also. Okay.
Next, I would like to invite Dr. Swetha Amit, Senior Application Engineer at Entuple Technologies, Bengaluru, to conduct this session. With over 15 years of academic and research experience, Dr. Swetha has made significant contributions to antenna design and RF component development, particularly in defense and industrial sectors. She is a certified Ansys professional in high-frequency engineering and has been recognized by the Defense Ministry in cutting-edge tools like HFSS, SI Wave, and an inspiring mentor for this workshop. She will be joining us online. Ma'am, please.
Thank you so much. Thank you. Good morning to everyone. Today's session, we will focus mostly on something called as EMI and EMC. So before I move into that also, so we will simply discuss what causes this EMI, EMC. Before that, in the word of EMI and EMC, there is two things which is common, that is electromagnetic, right? So give a thought, all of you, what is this electromagnetic? Can I call these as waves or signals? As simple as that, as basic as that. Can I call these electromagnetic? I mean, we generally call it waves, right? Why don't I call it signal? That's the first question which should put a small curiosity in your minds. And next comes is, what is happening with interference there? Something's going wrong there, right? These electromagnetics which are getting generated by some reason are getting interfered. And I need to find some compatibility because it's making some issues. So what is this? Where did it originate? How does it originate? What is causing this interference? And how can I provide compatibility to it? So after that, having known basics of these things, we will then enter into how can I visualize all these things in my in a electromagnetic simulation tool, that is Ansys HFSS. So it's a tool which is provided by the company Ansys. HFSS is basically a high frequency structure simulator. So using this tool, how can I visualize electromagnetic waves? If it is interfering, how is it happening? Can I visualize it? So all these things could be seen, and then we will take up a case study in our tool itself, and I'll show you a demo of what all can happen which makes me visualize these kind of EMI, EMC cases. So I'll present my screen. Please confirm if it's visible. Is the screen visible?
Yes, ma'am. Yes.
Okay, great. So I think Dhanush has given a brief introduction of what we are, what we do at Entuple Technologies. I don't want to go, anything in detail about it. So let's start here. Electromagnetic energy is everywhere. So in the picture, can you, I'm sure you can recognize each and every one of the diagram put out here as to what kind of communication is it happening. So even if I consider satellite communication, aircraft flying, autopiloting, a missile which is launched, a rocket which is launched, I have an Earth station there which is communicating always with the satellite antennas there. So all these things, when I look into it, right from there, if we go on with this lightning strike and all, yeah. So how do I relate this? How do I understand what's happening with these energies? So if I consider a wired system, so what do you speak about? If I say I have a source, a generator basically, and I have a load, which we all do in every practical situations, right? Or in our lab also. I have a source. It could be as simple as a rectifier circuit and as complicated as an amplifier or a very oscillator, which I am generating for certain application. So in my wired scenario, we always consider it in terms of voltage or in terms of current or in terms of power. So all these things are my signals. As long as it's in wired, so it's either we talk in terms of one of these, depending on what kind of application I am seeking. Yeah. The moment it comes out in air, in the wireless medium, or you basically call it as unguided medium, right? So wired is my guided medium, and when I throw out this signal into unguided medium, what happens? So these are called my radiations. So energy which is put out in outer space in my wireless scenario. So I now no more talk about what is the voltage level at any given point in my wireless scenario, right? So I don't say I'm right now sitting in my office. In the cafeteria, if I want to measure the intensity of whatever energy is thrown out, do I take a voltmeter and go in air and find out? No, absolutely no, right? Something's getting converted to something else. So this structure, which is exactly there in between this wire and wireless medium, is called an antenna, which throws out the energy, which accepts the energy. So this antenna is also a transducer, isn't it? So what's a transducer? Basically converting energy one form to another form. So this antenna, which is now getting a signal getting an energy in terms of signals, could be in terms of voltage, current, or power. The moment it comes to load, now my load is antenna itself. So it's taking it and putting it in wireless medium. So now it is acting as a transducer, converting my energy into electric and magnetic fields or electromagnetic waves. Yeah. So we have an equation, right? H is equal to half CV square, and E is equal to half CV square, H is equal to half Li square. So I, having known my capacitance and inductance, current and voltage in the wired medium, I can easily calculate how much is the wireless energy which is thrown out in nature, in wireless medium. Yeah. So when this is happening, so electromagnetic energy is put out now. So it's everywhere. I mean, you yourself think of the cell phone what you are carrying right now. What all communication do I have in it? Do I have GSM, the cellular communication, which is happening at around 900 megahertz? I have Bluetooth, which happens at 2.4 gigahertz. I have my location, GPS happening in L band, that is 1.57 gigahertz. And then Wi-Fi, since it is getting congested at 2.4, it has moved into 5.8. And then the world is moving towards next generation millimeter wave antenna, 6G, 7G and all when it comes up at 28 gigahertz. You listen to FM, right? Radio, anywhere. So that happens at what frequency? 100 megahertz, somewhere there. Along with this, there are a lot of other signals which are happening. Yeah. Pullers communicate with each other with the walkie-talkie having a certain frequency. So every wireless communication, what we look into, has to have a frequency of communication. Yeah. So when I talk about this, each frequency electromagnetic waves, do they interfere by any chance? Just a simple example. I mean, have you ever come across anywhere wherein there is some interference happening due to someone else getting a call, someone else getting a message, and you have your phone or your device has picked up that energy? Could be any reasons. Could be as simple as when I'm getting a call, I'm near a mic and that picks up some energy and we get a beep, right? So as simple as that. It can go to as complicated as, I'll give you an example in the next slides, that what all damages it can cause due to this electromagnetic interference. In good old days, a simple example, if I want to tell, maybe a decade back, whatever we had this satellite direct to home network television signal, right? DTH services. So there, even though between two channels, whatever could be an adjacent channels, which is happening at around 400 megahertz or something, all these communications down converted to that frequency from satellite. So when this is happening, two adjacent channels, even though we have given a very good guard bands and everything, there still happens a interference. Nowadays, we don't see. If 10 years back, we would have seen our television going into something called as scrambled signals. So do you know what is scrambling? I mean, I'm not talking when the signal gets deteriorated when it rains. That's a different logic at all. The wavelength, water droplet size gets absorbed, etc., etc. So I'm not going there. I'm only telling that during a very good day, I still get scrambled signals and my television reception is not happening. So that has happened because these two adjacent channels could be anything, okay? They were all designed for linear polarization. So having traveled a huge distance from satellite to my home, so there are possibilities that though it is two different frequencies, the polarization is the same, hence interference had occurred. Nowadays, what researchers have done is they converted these alternate channels into right-hand circular polarized signal, and the subsequent would be a left-hand circular polarized. So with this, having introduced circular polarization, so when I speak about polarization, all you have to visualize is how exactly these electromagnetic waves orient in wireless medium. It's nothing but orientation, okay? Nothing to worry about what is this polarization about. If I want to predict or if I want to draw the electromagnetic waves in a certain way, I can control it having a linear circular polarization. So you just have to take your right hand, rotate it in right hand clockwise. That is called right hand circle. That's how your right hand circular polarized goes. Rotate it in anti-clockwise, it will be a left hand circular polarized. So that's how the adjacent signals were configured, and now we don't get any such interference or something happening. So if I look into basic simple example of how does these electromagnetic interfere. So as you are seeing on screen, so what happened was this is in my 80s, 81 and 87, 5 US Black Hawk Army helicopters, no, they crashed, and yes, all on board passengers were either injured or killed, because it happened when they flew near radio broadcast transmitters. There is something, those days it was very difficult for anyone to find out what's happening. So the first reason what was insufficient immunity to the threat. There was no shielding provided to these helicopters, so that it is controlled against the high intensity radiation fields that is occurring from these broadcast towers. Okay, so broadcast towers could be anything. Could be as simple as AM, FM towers, could be a base station. So when these helicopters were flying over there, due to this, the complete interference of your complete cockpit getting malfunctioned, so it used to crash. So this is where the people started observing is something's going wrong. Yeah. And next, I would give an example of unintended missile launch happening. So when did it occur? Where did it occur? I will leave it to you to find out, because that's something which actually interests you, right? So you should be very thrilled to know how it is happening, why it's happening. So with a B-52 missile interface unit, so it just launched on its own. So the only reason was there was a crosstalk in the system wiring. So this had nothing to do with wireless world at all. So in my problem with my system wiring only, there was a small crosstalk. So that ignited it to launch the missile itself. Something a small error of a crosstalk had led into such a big blunder, right? And next is a foundry worker died actually of a radio when he was when a radio controlled overhead transponder, it dropped a few tons of liquid metal on him. So this was an accidental signal which happened, but but still a person had to lose his life for it. So these are the causes of magnetic interference, and also this tornado fighter case. So I would request everyone to Google it. What happened in 1984 near Munich in Germany? A tornado fighter crashed after flying too close to a powerful voice of radio transmitter. So why it happened, what made the cockpit engines or the electronic equipment to malfunction to get to this way. And as simple as, okay, not entering into aerospace and defense, even in a commercial experience of some powered wheelchairs, expected experienced unintentional movements, when police or fire transmitters were active nearby. So I mean, it's that crucial for you to not think about electromagnetic interference now. So it's something I have to take care of. It's something I have to make sure that these kind of interference doesn't happen. For me, police and fire transmitting has to happen for its own application. So whatever other applications have to happen, again, yes. So I lead you to one of the natural electromagnetic interference which is happening. Can anyone guess what is that which is happening in nature? Ships disappear, aeroplanes disappear in that region. Can anyone guess to yourself? I'm talking about Bermuda Triangle. So what is happening? Why is something, they talk about electromagnetic interference itself, right? So it's something that there is a huge electromagnetic field generated deep in the ocean. Maybe aliens have kept it or something, I'm not sure. But there is something going on there, and that is making all my electronic gadgets work weird there, and something's going wrong, right? So right from there to whatever we are seeing till date, so as you see on the screen, everything is related and everything has to communicate. Not only talking about wireless scenario, okay? It's even in wireless. When you talk about power lines, how exactly that can cause interference to a person who is standing right beside it. So those things we have to check. So right from a microwave relay link to the power lines to whatever kind of broadcast message I'm looking into, cellular, mobile communication, shipping lines, aircraft, radars, earth stations. So everywhere I have emitters of interference, and how exactly can I, what is it that I need to manage? So coming to having seen what exactly interference are due to electromagnetic waves. So now we will enter into what is this world of EMI and EMC? Well, I have to have emergency telecommunication system, air, marine, land transportation system, safety systems, all of which EMI can greatly affect if it is not functioned properly. So I'm talking about something which is used in commercial, which is used in defense, and which is used in safety systems. So right from the cell phone which I'm keeping in my pocket to a fighter plane or naval warship which is being launched or which is being used. So what is this electromagnetic interference? So with the prior examples, I'm sure you have now understood that electromagnetic energy is something which affects the performance of existing electrical or electronic equipments, which creates some undesirable response, or it can completely cause failure. Yeah. So what is this electromagnetic compatibility? Due to this interference, now it's my ability of a system which is actually getting affected to function very well without causing any degradation due to an intentional or unintentional EMI which is occurring beside it. Okay. So I do have lots of electrical devices and electronic devices beside me, and I have to make sure that they all are operating on their own. Due to someone else, my component should not get spoiled. So for a generating, so both are very important for me. It's important for me to find out where exactly electromagnetic interference is occurring. And it's also important, once I find out where the problem has occurred, where it could occur, it's necessary for me to give a electromagnetic compatibility. N number of companies are working vigorously on EMC. There are certain standards which I'll come to the next. I mean, I have come across most of my colleagues and friends who are full-time working on EMI, EMC, right from a small device which we use for day-to-day and to defense sector and commercial purpose also. So when I come to electromagnetic interference, so it's basically the differences that's causing a degradation. So compatibility is how do I make sure that my equipment is functioning properly even when there is disturbance. So I like saying we EMI. Am I deliberately doing something so that EMI is caused? Obviously, we don't do it. No, naturally, which is already occurring could be due to the electrical storms, the lightning, solar and interstellar radiation, rain particles. So these could cause. These are all examples for my natural EMI. When I come to man-made sources, so it's sometimes it is intentional, sometimes it's unintentional. So when I go to unintentional, it could be any kind of commercial radio and telephone communication what we use. Okay, intentional could be jamming. So I, or for a reason, would jam a circuit for whatever it is. Our electromagnetic pulse bombs. So those could also be used to trigger some intentional EMI. Yeah, so mostly used in defense purpose. So those are intentional. Okay. So if it is unintentional and it is occurring in my day-to-day activity, so what can I do for it? Even that goes with natural and man-made also. When I look into this, so this gives me a clear picture. Yeah.
Ma'am, Dhanush, can you please mute your mic? Dhanush? Mute your mic, some noise is coming.
That's called electromagnetic interference. Okay, well, please take a minute time, digest what's put on the screen. So EM environment components basically could be a man-made non-communication or a man-made communication type, or it could be natural also. So natural, terrestrial, extraterrestrial, or thermal noise. Solar flares, cosmic, atmospheric, rain, precipitation, static energy. Yeah. And man-made non-communication, if I look into radio frequency related, non-RF related, vehicles, computers, power lines, electrostatic discharge. So nowadays, whatever electronic components or huge devices, what we see with radio frequency or high frequency applications, right? So there's always ESD tools used so that I take care of these electrostatic discharges. I manage them. So if I take, that's related to non-RF. If I look into RF, it could be ISM band, ISM applications, industrial, scientific, medical application, or could it be a household application also? Man-made communication, which we have used for our good reliability, wireless communication. It could be a radar, broadcasting, point-to-point or point-to-point, mobile applications with respect to terrestrial or aeronautical, satellite communication, either it could be a geostationary or low Earth orbits, or if I'm communicating to a rover which is on Moon or Mars. So these are all man-made communication. So this is a complete EM environment which is happening.
Ma'am, sorry for disturbance. Is already two people just give request for joining meeting. Is no one guy also is give request Praveen, I think.
Okay.
What I will do? Admit or?
Yeah. Admit.
No, it's
Yeah.
not right. Okay.
Dhanush, we can admit everyone who's entering the. Yeah. Please enter.
Okay, I will.
Okay. Where were we? Yeah. So we saw the complete electromagnetic environment components. The effects of these. So I think I need not even explain this. So now you should be in a position to answer yourself. What is the effect of EMI also? Malfunctioning of most of my electronic components, could be a system level or a subsystem level, which can provoke an accident. So EMI EMC problems were first discovered, yes, by military applications in 1950s, and now more and more have been is suffering with civilians too, because I mean we want everything in our fingertips, right? IoT, industrial IoT, smart homes, smart. I mean everything has to get smart now. So I that's what we are life is demanding, right? So when the moment this comes, so many electronic things attached to everywhere. So that will definitely give rise to electromagnetic interferences. Yeah. So since it slowly came to commercial use, that's when the need for it, the research for it is happening vigorously. Even when I take a cell phone, now people are talking about something called as MIMO antennas, right? So in your cell phone, if you have bought a phone which is a year old or something like that, I have two MIMO antennas diagonally placed along your cell phone, and I have so many other antennas beside it. So this itself gives me electromagnetic interference. Along with it, already it can interfere with the circuit which is all PCB signal transmission also. I'll come to that later. So it is that sensitive. So I have to take care of many small things. So how do I, in a very simple way, if I have to start, how do I control these EMI, like interferences? So first thing is grounding. As simple as that, but very efficient. So have you come across somewhere wherein you are plugging a electronic device, and your body, acting as a good conductor, passes the energy through you and goes to an earthing? Yeah. So if I provide a proper earthing, all these things could be taken care of. So assume electronic or an electrical device which was supposed to work otherwise is not happening because I have not given a sufficient grounding. So first thing for me is to take care of the grounding. And then second comes shielding. Shielding is for ships or for helicopters. So this is what, as I told you, the aircrafts which was colliding previously in 1980s and everything. So those kinds were taken care of providing electromagnetic shieldings. Okay, there are a lot of such shielding, effective shielding, which are used right from as simple as paints. Okay, electromagnetic repellent paints, and now a lot of research is going on with metamaterials also to shield electromagnetic interference, and also to mitigate my radar cross section and all when we talk about naval warships and everything. And filtering. So this is basically for me to understand how much is the insertion loss. Okay, or let me say in a very simple way, find out how much is the electromagnetic interference which is occurring, and I'll put a filter there, as simple as to block it. So indirectly I am grounding that energy, whatever is coming. Okay, so these are all very simple ways for me to block the electromagnetic interference. Even in our cell phones, whenever I have so many things, a PCB along with so many RF circuitry added to it, so grounding is first and foremost thing which we have to take care of. So when I say it needs to be reduced, it needs to be taken care of, now I need to see that are there any standards which is given by either it could be defense standards or any standards which is given for a civilian, for me to take care of EMC. For everything there are standards, even when you are using your cell phones, right? So how much is the radiation which has to enter? So FCC has its own standard which says how much radiation can enter. As such, if I'm talking about electromagnetic compatibility, which I have to build in for me to mitigate EMIs, so military standards are 461 and 468. Civilian standards we have for different applications, commercial, industrial, and domestic applications, each given by CISPR, what we are seeing, no, International Special Committee for Radio Interference. So this is something which is managed, which is accepted globally with most of my civilian standards, and along with it FCC and PTA also. So now let's look into one of such standards for civilians, which is CISPR 25. So this is basically a international special committee which is organized for radio interference. So mostly which is part of Technical Commission, IEC, International Electrotechnical Commission. So what this basically covers is, so this standard measures and controls electromagnetic interference which can occur in vehicles, in boats, and in any other devices which is powered by combustion engines. So now you can relate to which of the commercial applications am I using, vigorously using EMI, EMC, especially CISPA25 for my vehicle V2V communication, vehicle to vehicle communication. So wherein I have combustion engines, I have high frequency sensors, I have radars, I have antennas. So all these things deployed in a vehicle, how exactly can I take care of it? Along with it, there are few more things which I can look into. So this standard provides or measures the radio disturbance which is occurring mostly in the frequency of 150 kilohertz to 2.5 gigahertz. So most of my communication which happens at low frequency and high frequency, it is covered now. Till my Wi-Fi frequency of 2.4, it's covered. It's designed to protect receivers in a vehicle from disturbance caused by any other component in the vehicle itself, in the same vehicle. So, so this regulatory framework is accepted by many countries to take care of my EMI compliance. Okay. So how do I check them? So before, how do I even deploying these? If I take an example of a vehicle itself, before deploying whatever I said, sensors, radars, antennas, engines. So how do I check for its electromagnetic compatibility? So how do I test it? So we have EMI, EMC chambers. So these chambers, as you see in blue color, the pyramidal kind, they are all polyurethane material, as simple as thermocol made material. A sophisticated kind of polyurethane materials which act like an absorber. Okay, so you would have seen in acoustic absorber in a sound recording system and all. So this is basically a RF chamber. Okay, high frequency chamber. Okay, I wouldn't say high frequency, right from whatever frequency we have mentioned, 100 kilohertz to 2.5 gigahertz or something like that. Till all the frequency, these absorbers are put along the sides of a wall, in the floor also, in the roof also. The size of these polyurethane absorbers mainly relate to the wavelength of frequency what I am covering. So if I am using a chamber right from 100 megahertz to 2.4 gigahertz, so not 100 megahertz, 100 kilohertz, to 2.4 or 2.5 gigahertz. So I have to go back and calculate my wavelength, and depending on that, the absorber size will be designated. And inside this, you see a kind of bow tie kind of antenna which is placed in a vertical position, right? So that's an antenna which is kept around 3 to 4 meter distance from EUT. EUT is nothing but equipment under test. So I have created equipment. So I need to now find out what is the reflectivity, or what kind of reflections is it putting out. So I have kept an antenna for me to absorb or receive these reflected signal from an EUT and understand how much is the electromagnetic interference happening. Accordingly, I can suggest how can we come up with the electromagnetic compatibility also. Okay. So normal incidence performance of absorber. So it is done in a chamber because otherwise it will be very difficult for me, because there are a lot of multipath reflections happening. So in a chamber, it's like, even though it's a absorber, due to its wavelength sensitivity and the material use itself, there is no absorption happening in the absorber. Okay. So it reflects back. So all the signal gets reflected back. So it will be like a ideal vacuum or ideal condition for me to test every device. So even for an EMI, EMC, or for any RF component which I design, either it could be antenna, if I have to find out its gain, which I've used for any application. So we use these kind of anechoic chambers or EMI, EMC chambers. So in detail, if I have to look into it, so I have the side view of it, which shows me a bow tie antenna, which is fed through a transmission line, and I have a EUT, that is the equipment which is kept under test. And we also see that there is something called as LISN, so line impedance network. So if I have to give input to my device which is under test, so I give it through the line impedance stabilization network. So because whatever input I am giving, at least in the initial go, I have to make sure that it's a stable signal which I am giving. So line impedance stabilization network it is. So it is whatever input power supply we give to LISN, it goes through the device, and whatever device functions, so this antenna absorbs or takes up that energy which is reflected from the EUT. So this is where I know that EUT, the cable lines, LISN, everything is connected in a wired scenario. Okay. So if an antenna is taking that energy means, so there is some emission which is happening, right? So if I talk about emission, there are two types of emission. So one is conducted emission, one is radiation emission. So here what I am talking about is radiation emission. Okay. So it's radiated. Something is emitted, radiation is emitted, so which is absorbed by this antenna. So that gives me a very good observation that when I am using a device, when I have designed a device, it could be
Hello, ma'am, sorry to interrupt.
No, please.
Yeah, you can use a marker to show a bow tie antenna or receiver. Yeah, that laser pointer.
Yeah,
okay.
that will be good.
Yeah.
Okay, great. Okay, so this is my bow tie antenna. So looks like a bow tie, hence the name. And this is fed through a transmission line. Whatever feeding we do, we don't do it inside the anechoic, EMC chambers. So it is the feeding, the power is always launched outside only. So this might be connected to a vector network analyzer or a spectrum analyzer. So this is my wireless scenario, this whole thing. Okay. And this, whatever I see kept on a table, is my equipment under test, and through which the power lines go till my LISN. So this is my line impedance stabilization network. I have to somehow feed the EUT, so it goes via LISN, so that input what I am giving is perfectly matched. So something called as, we go with as simple as a maximum power transfer theorem, wherein it says that whatever power I am feeding it is perfectly matched with the impedance of the test device which is under test. It could be a DUT or EUT also. What is the dimension of these things? This is a typical example of one of a chamber which is already existing. So I've just taken the same example here. So now when I give power supply to EUT via LISN, so this is my wired communication, so which I would probably deploy it in my vehicle. So this is working fine, but due to this, if there is any emission which has occurred or radiated, would be captured by this antenna. So that would give me a very good clear picture that this as such, if it is working, due to this, is it causing any electromagnetic interference to the nearby device? So if I keep a nearby device, the device could malfunction. So, or in a better way for me to understand is, put an antenna designed at certain frequency at which it is radiating, and if this would absorb the energy or not. If we can check that, so we definitely know there's an electromagnetic interference which is happening, and then we will plan about giving it proper shielding, proper covering, could be of any material, so that this radiation does not interfere with any other devices which is kept beside it. So this is a standard CISPA 25 chamber setup. Okay. Yeah, so another example of, you can see in few different sectors, wherein the chambers would be so big that a complete vehicle or an aircraft can enter it, integrate all your sensors, all your electrical devices, electronic devices to it, and find out what is happening to it. a 10-meter emission test is done. So I will have log periodic dipole antennas. It could be, I mean, what we used previously was a bow tie antenna. I can either use that, I can use a log periodic antenna, I can use a biconical antenna, I can use a horn antenna. So any of these three antennas could be used for these applications. So I have my vehicle here, and any of these antennas would be placed at 10 meter, and the emission test will be checked for it. Okay, so this gives me a complete picture of automotive testing. Okay, so now till here we understood what is EMI, what causes EMI, and why is it necessary for me to provide EMC also. So if I have to talk about one of the standard, we considered CISPAR 25, which is mostly aligned with vehicle EMI EMC check. So these were all the basics, what existed and what we can do, and why should we be very careful in considering EMI and EMC. Now comes, how can I inculcate all these things in software itself? So if I have to design something and straight away fabricate it, test it, I don't know where I'm going wrong, right? Simulation is one such platform which gives me a complete independence and leverage to play around so many things. I mean, it's as good as me having a digital camera and an analog camera, right? So there you have to think how many photos you take. You take one, you need to wash it. So how about digital cameras you are using right now, or your cell phones also, which otherwise take 100 in the same pose and delete 99, which you don't need. Yeah, as simple as that. So simulation is basically a wonderful tool for me to play around many things, many other things also. So just as a simple example, if I have to talk, Ferrari has bought our tool, Ansys. So any vehicle for that sake, always when it is manufactured and good to go, it has to go through this car crash tests, right? So everyone knows this. So car crash tests was happening live, like speed, elevation, angle, distance, everything was checked, everything, and how does it impact the vehicle. I'm talking about mechanical world, right? The same thing is now put in simulation platform. So now Ferrari is like using the tool left and right to do things which otherwise wouldn't have happened in real-time scenario also. So imagine the same thing being used with every other thing. I have radars deployed on for my ADAS applications or something. There could be blind spots, obviously, right? Even when I am sitting in my car and driving, there is definitely a blind spot when I am looking to my right, when I am looking in an angle at 45 degree, due to whatever it is. We know it, right? So even the same thing goes with an electronic equipment also. How do I understand this? So when I put all these things in my simulation platform, the whole complete scenario of a vehicle, there is something called as a digital twin. Digital twin is nothing but replicating everything in a digital or a virtual platform, which coexist as a real-time scenario also. It could be as good as simulating or digital twinning my body itself, because I am using too many things beside me. I have a pacemaker, I have a titanium rod put in my leg. I want to simulate it and understand if I'm using a phone due to this titanium rod and all, is my body temperature getting heated up? I'm just giving you few examples wherein you can think what all possibilities could be done in my simulation platform. Okay, not for my cell phones. I have created an antenna for my base station itself. So if I want to look into a complete how exactly this antenna radiates in my surrounding all my buildings and moving vehicles and all, I still can replicate that in a digital twin. So I can replicate a complete vehicle, put all my engines, all my sensors, everything, and then find out where exactly my electromagnetic analysis needs to be done. So it could be with respect to electrostatic discharge, or it could be with respect to cable harness. Cable harness is, we have laid so many cables, so many things needs to be communicated. So how do I understand the crosstalk happening? How do I understand if the cable otherwise is straight or it is twisted, will there be any losses there? And if I have placed n number of antennas, so how do I place it? Where do I place it? Is it necessary for me to figure out where I place the antenna on an aircraft? Or can I just place it wherever I want? Same goes with the vehicle. Same goes with every other application. Why is an antenna exactly at that position in a laptop or a cell phone and not in any other place? Did they randomly put it there, or was it well planned so that it manages the PCB, it manages the coverage, it manages how exactly I move my finger so that the radiation doesn't affect? Yeah. So everything is taken care of, and we can have a full platform simulation, as I told about digital twinning. So in this case, if I want to check radiated emission, and how do I get immunity for it? That is nothing but EMC. So design and development of EMC or EMI goes in this level. We take care of component level performance and then check the cables. Then we integrate all these different kind of antennas which are there and produce a complete platform which gives me each one, what we see here is an antenna and it is putting out radiation. This is how my radiation pattern looks like. Could be FM, could be GPS, could be my Wi-Fi. So any communication which, or could be it could be a radar for me to find out the neighboring vehicle which is moving, the distance and all. So for all these things, we use the electromagnetic analysis. So if I look into only the antenna and RF CUSAT, so a number of antennas placed here. So antenna to antenna complete also should be taken care of. So this frequency, this plot gives me what is the S parameters which is used for a frequency of 0 to 3 gigahertz and with respect to S parameters. So S parameters is my wonderful plot which tells me about a good impedance matching which is happening between the antennas, and that in turn will tell me is there any coupling happening between them, or if there is a coupling happening between antenna to PCB also. So now when I say antenna, so it's mostly for my radiation which is happening in wireless medium, right? In that wireless medium I have two types. One is near field and another one is far field. So why differentiate near field and far field? So as the word itself says, something which is happening near the antenna is near field, something which is happening beyond the antenna is far field. So how do I differentiate how much is near field? So there we already have an equation, R is equal to 2d square by lambda. So d square will give me the dimension or diameter or length of 2l square by lambda. So this gives me the the dimension of the structure, 2d square by lambda. Lambda is in turn will give me the frequency, lambda is equal to c by f. So at what frequency I am operating, if I know the dimension of the antenna, I can easily calculate near field and far field. So why is it important for me to calculate near field and far field? Or why am I interested to know about it? So there's something very interesting happening in near field, okay? As simple as if I give you an example of someone, assume there's a stagnant water, okay? And you throw a stone inside it. So what happens when you throw a stone? So I'm sure everyone are imagining how exactly the ripple occurs, right? So that's a good thing of it. So this ripple occurs depending on the intensity at which I throw the stone will be the ripple coverage also. With low intensity, if I put, I may get 2-3 ripples. With high intensity, if I throw the stone inside water, more the ripples. Exactly same as how this antenna is working. Give more the power, more will be the distance covered. But I cannot play with power, right? We are surrounded by living things also. There is a certain amount of radiation beyond which my body cannot take, which otherwise I will get roasted off. my question is, what happens exactly where the stone is touching the water surface? Do you see some disturbance there? And then the ripple starts, right? So the point or the area or the circular area at which the disturbance is not uniform, that's what happens with antenna also. So when an antenna is throwing out energy, right at certain point, a small distance, small range near the antenna, there is this disturbance wherein exactly like the disturbance which is occurring when I throw a stone in the stagnant water. So this is a point where my electric and magnetic fields are not perpendicular to each other. Okay, beyond which when the ripple starts occurring uniformly, that's my far field, where my E and H are perpendicular to each other and are perpendicular to the direction of propagation. So in this near field, it gets very, very, very difficult for me to solve. So you would have seen a few, excuse me. You would have seen a few cell phones having NFC, right? Like that Harry Potter thunder lightning, not Harry Potter curse on his head, same symbol, right? So it didn't click much. Had it clicked, I could have easily ruled out Bluetooth and Zigbee and every other short distance communication. It didn't work out because for a researcher to understand electric waves and magnetic waves, which is not perpendicular to each other, gets very, very, very challenging. So if I have to find out my EMI EMC, near field is something I'll be bothered about rather than far field communication. Far field is done. My antenna is throwing energy, someone else will take it at a far distance. So when I'm talking about RF CUSAT is nothing but n number of radio frequency which is being generated by these antennas in a single site, in a single instrument or in a single vehicle. So how exactly it's happening, and how do these different antennas exist without interference? So all these things I can take care by placing it in different way and finding out my terminal S parameters. So this S parameters basically gives me how much is the incident wave and how much is the reflected wave, which directly relates to my VSWR, voltage standing wave ratio, and my Smith chart also. So this is how we check. So once I design my antenna or I place it on my on the vehicle, so all these things could be done in Ansys tool itself, and I can find out how exactly the CUSAT interference is happening. If it is happening, how do I mitigate it? Yeah. So once I have checked that, so if I want to do it with respect to CISPAR standards of 12, 25 or 36 or IEC standards also, so I have to now launch it in an EMC chamber, right? So the chamber what I showed you previously is available in most of the defense organizations. So we can go there, place our equipments there and check it. Or if I want to do the complete EMC chamber, in the simulation scenario itself, that also could be done. Whole chamber would be created using our exactly like the polyurethane materials as an absorber, and then I can place my vehicle, append all my engines, sensors, cable and everything and calculate complete EMI EMC analysis. So right from designing a small motor or an RF device, putting that in a vehicle, creating a EMC chamber, deploying you can see here there's an horn antenna here. So whatever radiation emissions which is occurring due to this will be captured by this antenna here, and then I will know how much is the electromagnetic interference, what kind of compatibility do I need to give. Yeah, this is how my simulation platform looks like. These are all my absorbers. This is my equipment which is kept under test. So due to this radiated emission which is being absorbed by the bow tie antenna which is placed at around 2-3 meters from the device. So what does it take? So if I look into the simulation and measured values, both are coinciding at each other. Yeah. So it is that accurate. When I use my simulation platform to check all these things could be done. It relates to every thing which I otherwise do it in a real-time scenario. So what all examples or what can be done in Ansys tool that is in HFSS? So I can go as simple as bulk current injection. I can check for radiation emission. I can check for electrostatic discharge. Could be radiation hazards, RAD-HAZ, which happens in military standards. Could be electromagnetic pulse and Mises power 25. Okay, conductive emission or radiation. So these two is what I was talking about today, and a lot concentrated about the radiation emission, what is occurring. Yeah, so what all could be done in a software to understand the whole thing, as simple as I can start with the component level design of a system, right from having a amplifier, a lumped component of RLC, make it a system, then have many number of subsystems attached to make a complete wireless system performance. How does that impact to the nearby antennas and RF bands? If I'm using different frequencies, is there any interference between them? So link power link budget is nothing but mostly happens when I'm communicating from my earth station or from my base to an helicopter, or it could be earth station to a satellite. So how much is the power link power budget? So EI, isotopic radiation power. So those things can be checked with this. So everything could be done in a simulation platform also. So with Ansys, so it provides key features to address all these challenges, right from high accuracy EM simulation, which provides my electromagnetic fields with respect to different dielectrics. So how does it work is mostly with the logic of dielectrics. So we are made by so many things, each one has its own dielectric property, right from your skin, your fat, your muscle, your organs, everything has its own dielectric constant, your blood, your anything else. So having known that, I can easily calculate hazards, which is basically electromagnetic radiation to personnel, to ordnance, or to fuel itself. So these are all different radiation hazards which can be which encounters in ships or in high voltage lines or in my wireless communication also. So if I have to check SAR, it's nothing but specific absorption rate. So how much is the radiation which is entering my human body when I'm holding my phone near it? Yeah. So it's definitely less than what FCC has given us, but still, how much should I use? How should I hold my phone? To what distance should I keep? When you're making, it's as simple as when you're making a call, that's when your mobile signal goes to the base station, it will track the person whom you're calling. So I am using lame words for all these things. So when your connection is existed, when the call is picked and a dedicated frequency line or dedicated path is given, then your power gets stabilized. So even before that, it's as simple as do not keep the phone too near your ears. Why do you want to listen to a ringtone or when the search is happening? So your power, your too many things are happening in your cell phones, in your PCB. So from as simple as doing that to do not keep your phone beside you when you are sleeping. So simple things, because we cannot live in a world with mobile free, right? We need everything. We need cell phones, we need our smartwatch, we need headphones. I mean, everywhere these electronic equipments come, and the moment antenna comes, so many things are related to radiation absorptions. So all these things, if I know I have a platform wherein I can test it, so which gives me a very good, I can take a deep breath and understand that, okay, this is where I am getting a problem. Diagnosis is a huge thing. It's almost there. You can say that you have won it, the proper diagnosis. Even if it goes to medical or goes to electromagnetic interference or something, then I will give compatibility. For me if I don't diagnose what my problem is, how would I give it a remedy? So this tool is that powerful to give me what exactly can happen. So, for me, it gets easier to find out electromagnetic compatibility also. So if I'm talking about electromagnetic exposure to human body, what kind of electric field plots have occurred in high voltage, and even if a vehicle is passing through it, so with whatever electric field high voltage lines are emitting, so how does it affect the vehicle or something which is passing through it? So what kind of, so all these things are now come up with shielding effectiveness, so that it would not affect the person or a vehicle, whoever is moving near the vicinity of these high power lines. Yeah, so application, smartphones, I already spoke about. It could be smart home, it could be a stadium also, where I have so many such antennas deployed. Will there be RF CUSAT happening? So there is something called as a desense. So a lot of research is happening in this. So assuming that I have a simple circuit of my camera itself. So since I didn't speak about it, let me take a camera, and there is some circuitry inside a camera, right, which gives me some internal circuit. So this signal, what is passing through it, that signal can also affect the antenna, which is, so if I have a camera which is Wi-Fi enabled, so I have a Wi-Fi antenna there. So whatever signals are passing through it can interfere with the antenna's performance also. That's basically called desensing. Huge research is going on in desensing, and that also could be done in my in our simulation platform to handle it. So this was mostly about the complete overview of what is electromagnetic interference, what are few standards, in CISPAR 25 what happens, and if I want to test the same thing in my simulation thing, how does it happen? So before I go into showing a demo of this in tool, if there is any questions, we can just have a quick discussion, and I'll go into my simulation environment. Any questions, you can please feel free to ask. You can put it in the chat box also. Anything to discuss? You can, if any questions, you can share it with Dhanush and he will ask the same.
Conducted emission susceptibility, is it all covered in the software? Because you mentioned
Yes.
only radiation efficiency, radiation emission.
Yeah. Everything is covered, ma'am. Since I'm a high frequency engineer, so I mostly on the radiation emission. So conductive emission is also possible. Definitely, yes.
Okay.
Any other questions? If you are going with some RF products, what are the we had some CISPA 25 like that standards, right? So what are the standards that has to be satisfied for some defense or military applications?
Yeah. Mills, there are certain mill standards of mill standard 461 and 462. Each one has its own compatibility and compliance tests, which we have to adhere to. So each standard has its own thing to find out how much is the EMI, EMC. So each one has its own application, either in terms of defense or in terms of my commercial or civil applications.
Yeah, suppose if we are coming with some radar or something like that, and if we are indigenously doing that, so whether the government of India or the world as a whole has some standards, they are sticking on to that for that kind of products.
Correct. Definitely, yes, sir. They are. So every product you design, if it is for a defense application, it has to go through the MIL standard. So I myself have not worked on any project right for defense applications. So one of the, I can give you a simple example of one of my defense project which I did was to design a antenna on helmets, so bulletproof helmets. So for this antenna, it was a flexible conformal antenna which was designed for GPS and Wi-Fi frequency. So we had to go through JSS Penta 5 standard, which was rain, moisture, pressure, temperature, and all these tests. So each one, if you are designing a radar, probably it definitely has to go to Penta 5 standards and few of the military standards also.
Okay, thank you.
Yeah, sure.
Ma'am, you are mentioning about electromagnetic compatibility studies related to biological tissues, the effects of electromagnetics on biological tissues, right? So, my question is, being a non-ionizing radiation, what is the significance of this study? I mean, actually, it is the body is just getting heated up, right? Is there any other repercussions related to that? I mean, there can be other ways of getting heated up. A body can get heated up due to other radiations or other effects. So, what is the significance of a biological tissue getting heated up due to such microwave radiations? Why are we focusing on the studies related to that?
So yes, as you told, it's non-ionized signal. So I absolutely don't have to worry about too much hazards which can happen on human body. First thing. So I'm considering a non-ionized signal itself, which is entering my body, which directly relates to my temperature behavior. So even whenever we design an antenna or a RF component, in our tool itself, we have something called as ice pack. So we take all the body behavior or a phantom itself or a torso and place our RF component beside it and see how much is the thermal emission happening, which in turn is deteriorating the performance of the component itself.
Okay.
It could be an external device or it could be an implantable device also. So two things come here. My device itself might get knocked out, or due to the temperature, how exactly is the water molecules in my body getting disturbed? So which would eventually give rise to something else in my body. Definitely not leading to major things, but yes, otherwise 70% of body made up of water. So how exactly it's affecting? So those things could be analyzed.
Okay.
So next comes something called as, in Ansys tool only, there is fluid dynamics also. So if due to the temperature rise, if there are any fluids in human body which is moving at a different velocity, so that is something which could be analyzed also.
Yeah, ma'am. You can start with the hands-on now. Hello. Ma'am, can you hear me?
Can you see my screen?
Yeah.
Okay.
Yeah, we can.
Okay. Setup of which was developed, and the same thing if I want.
Ma'am, your voice is breaking.
I would. Now?
Yeah. Now we can load.
Thank you, Nathan. Electronic Ansys high frequency HFSS. So high frequency structure simulator comes with Ansys electronic desktop. So which and show you what. So in electronics desktop, lot of tools which could be used. You see 3-dimensional which I can use for a 3.
Hello, ma'am. Sorry to interrupt. Your voice is breaking.
Already explained.
Your voice is breaking, ma'am.
Okay, just Okay, just give me a minute.
Yeah.
Ma'am, I think Dhanush side is the network. Your side is okay. I think Dhanush side is the network issue. Hello, ma'am.
Yeah.
Ma'am, your side is okay. I think Dhanush side is network issue.
Okay. We will wait for his reply.
Okay.
Hello.
Yeah, Dhanush.
Yeah. Now it will be sorted. You can start the answer now.
Sure. So when inside the electronic desktop, we have high frequency structure simulator. It could either be done in 3D platform or in a circuit platform also. So I have Q3D if I want to check the lumped component values, the resistance and reactance values or at any given point in a PCB or in a circuit. So that is mainly for my Q3D. We have ISPAC, so basically for thermal analysis, and Maxwell for my low frequency applications with respect to motors and everything. So, and I have mechanical also if I need to check if there is any deformation occurring in any of my device due to temperature variations. So these are all the tools which could be used to analyze, and along with it we have SI wave, so that is signal integrity and power integrity. So if I have my PCB and I need to check in a given trace in an IC how is the signal flowing, so those things can be checked there. Coming back to my an environment of CISPAR 25 radiated emission. So this is how the environment looks like. I have a complete chamber walls. So this is my chamber wall, which is again as good as it is created with vacuum. So we don't. There is no use of putting a polyurethane absorber also, which I showed the other page. So real time, if I have to create it as a vacuum scenario, I will have to use the polyurethane things. So that I will just hide it for now. And this is my chamber floor, which is completely ESD balanced, discharge taken care of. And next I have I have interfaced wooden table so that I doesn't have any kind of. So this is the main thing which falls in for me to check. So as we see here, we have a bow tie antenna, a biconical bow tie antenna, and I have the EUD. So this is my device which is under equipment under test, and through the cables I have my LISN here. So the line integrated network. This is an enclosure given to it. So with and without that, what happened and how exactly the antenna is taking the emissions, I'll just show you that. So I will just hide a few things which we do not need to visualize actually. So this is a complete setup which has to be done if I have to check for any kind of radiation emission or conduction emission for that sake. So I would say since there are a lot of examples already existing here, when we check here open examples, we have HFSS, and I go to, in this there are a number of things, right from ADAS or a simple component level of antennas, EMI, EMC, filters, metamaterials, or if I am checking RCS or signal integrity or a transmission line. Each one has its own significance and importance. So if I check here, so I have my bulk conduction could be, there's an example. CISPAR I have for conducted emission and for radiation emission also. Electromagnetic, the pulse, if I have to check, or an ESD enclosure with some slots. So those are radiation hazards with respect to mil standard on an ship. So if I have, so those lot of, few examples are there which could be used to understand how exactly the circuit is designed and how it is launched, and you can append your own devices, change the device under duties, and check how is the radiation emission happening or a conducted emission happening also. So these examples would be very helpful, and along with it there is something called as HFSS help here. So a lot of PDF are already there for a start. So this PDF will give us line to line information about how we can develop things right from scratch. Want more information? There is innovation course which which Tanush has spoken about. So, and we can learn a lot of things with that. So coming back to the main equipment which is used for my CISPAR radiation. So basically three things: my antenna, my equipment which is under test, and my LISN. So as we see here, so three main components are used. So EMC chamber, if I have to create this, so I need to have this chamber to block any kind of external electromagnetic interference which can occur. So it could be an anechoic chamber with absorbers, or the chamber should comply with CISPAR 25 specifications. So NABL certifications has to be done if I am using a chamber for CISPAR 25. So what happens is I have my EUT which is kept on a non-conductive material. So I can use, I've used wood here. So it's powered via LISN, so which is my line impedance stabilization network, and all the cables which are connected as per my standard design itself. So coming to LISN, why is it more important for me to feed the device which is under test via LISN itself? Is because of this filter noise which it takes care of, and it measures the conducted emission from EUT. So in this experiment, what I am showing, conduction emission can also be checked, which is inside happening here, or I can check the radiation emission also. So if I have LISN, so this measurement could be done, and I will have antenna to check for my radiated emission. I can use any kind of antenna, right from monopole, biconical, log periodic, or horn antenna also. So where do I place it? Mostly depends on frequency of operation and the quiet zone what I calculate inside the chamber. So for the frequency of operation which is considered here from 150 kilohertz to 30 megahertz, we can place the antenna at around 1 meter to 3 meter distance. Height adjustment and polarization changes may require depending upon the kind of emissions which it is used. So if I want to have horizontal polarization or vertical polarization, my antenna will be adjusted accordingly. So if I want to measure conducted emission, so LISN is connected, and here this LISN will be, measurements will be taken using a spectrum analyzer, so which is connected outside the chamber. So frequency of operation, and then comes my radiation emission which will be captured by the antenna which is placed there. So this EMI receiver measures the signal level at most frequencies, right from 30 megahertz to 1 gigahertz. Usually the real-time chambers, if I have to check for EMI, EMC, don't go from 1 kilohertz application. So we usually start from 30 megahertz because the size of the chamber depends on the frequency of operation, which in turn will be the wavelength. So lower the frequency, very high will be my wavelength, which in turn has to be huge chamber size. So if we can do that, yes, else mostly it starts from 30 megahertz to 1 gigahertz. So key things which I have to take care if I have to calibrate all these things is my calibrations, all the instruments, all the cables, antennas, LISN needs to be calibrated, grounded, and it should be taken care of cable harness also. So how do we check here is, so with the antenna, the setup which we have created, which wherein this biconical antenna operates from 30 megahertz to 300 megahertz. So that is within the radiation emission which occurs for the DUT what we have kept. I'll just hide few things which I don't need right now to explain. So there's a table which I have kept for a reference, which is given a material of finite conductivity. So every material what we choose has its own library in here. So if I want to design a material, there's a huge library wherein any material could be chosen or assigned. So assuming that I have a material here, I have a structure created here, right from any kind of dielectric material to whatever is available, metal or high dielectric constant materials, or it could be non-conducting material. Anything could be, everything is there in the material library. If not, we can always add a material, and you can always, if it is related to temperature, we can give thermal modifier, or if it is frequency dependent, we can always make it use that also, depending upon our different notion of which material we are using. If it's a graphene or something, I'll use DRED model. So depending on that, any model could be used to have a frequency dependent materials. And also we have component library here. If I'm checking about EMI, EMC, I already have few of the standard cables already there for bulk injection, conductive emission, electrostatic discharge. So, and few of the generic antennas which are used for testing radiation emissions. So all these things could be used if we have to design anything on our own also. So the complete component libraries are there for us to understand here. So this is a support given for my EUD. I'll hide that for now, and the cable support I'll hide. This is my aluminum case which I have used for the line. So when I zoom in each of the component here, so this is my the device which we are planning, which is under test. So this is a casing which we have used to connect a female and a male, and the cable goes as such. And when we come back here, how we have fed the cable is, yeah. So this is my input. So these sheets what we see is basically the input what we are providing to the LISN cables. So as we see here, this is nothing but radiation emissions CISPAR cable 1. So this is, sorry, and this is for the load 1 and this is for load 2. So this is how we give input to these each of the, it's excited. So when I look back, when I click on excitation, so whenever I design any structure, first thing is my 3D component what I have used, and what are all the boundary conditions what I have used. That is, if I have to say the boundary conditions, either it is perfect E, perfect electric, perfect magnetic, or it could be lumped RLC if I have to use some diodes or something, or it could be finite conductivity. And so depending on what materials I have used, I can use the boundary. And I can use different types of excitation also. So depending RF discharge or multipaction or magnetic or linked bias, or it could be a simple lumped port or a wave port. So once I have created a model, I assign boundary, and then I give input to it. So we excite these structures, and then we give analysis, that is to tell the tool at what frequency is it operating, and then we simulate it and look into all the results and the field overlays also, which wherein I can visualize, animate, and check how exactly the fields are moving inside the cable and everything. This is the cable inputs what we have given. So in real time, so these cables come exactly at the border of the at the end of the chamber, and spectrum analyzer will be connected to it to feed it. So this is the complete. This is how a complete system is done. So if I want to check this in component level, in a circuit level, so this is how it looks. Yeah. So this is my LIS, and this box what we see is the a module wherein the complete EMC chamber is modeled inside it, and we give input to it with whatever DC voltage through LISN goes to the cable, and which get triggered to the EUT, and this input is for the antenna, and all kind of different outputs which I have to check with respect to the cable loading and with respect to my sysbar. So this is how the circuit looks like. So in HFSS, so I can model it in a 3D and then take this whole thing in the circuit and append my circuit to it and analyze the whole thing for my conduction emission. Radiation emission I can check in this environment itself. And with the biconical antenna, if I have to check, so this is where the biconical antenna is fed. So this is the input which is given to it. So when we see here, it's given for 30 megahertz, 300 megahertz. So this is how, if it is acting as a it is acting as a receiving antenna, and it will absorb whatever radiation emission is being put out here. So if this is already a simulated one. So if I look into the results, before that, so when I click on excitation, I have n number of things which is excited here. So this is one EUT of example one. I have n number of cables here, which each one I can test it. So I have taken 2 to 3 such inputs where for me to test it, assuming that the power is coming from LISNs, and these are the 3 different points where I have to give input to it to check how exactly this is working internally, which is yielding up in a emission which is happening otherwise as a radiation. So when I have to check about after analysis, so in analysis I will give to what frequency it has to work. So we'll start from 0 hertz or 0 gigahertz, 0 to 300 megahertz. So that's the full range of performance of my EUT and the antenna also. So once I have given this, we go and validate it. So when we do the validation, it is with respect to modeling, the boundary and excitation, mesh operation, analysis which we have given, and everything else set for it. So once I analyze it, so I can go and visualize my results here by right clicking here, either with respect to, it could be with respect to S parameters, or it could be with respect to VSWR, or it could be the Smith chart itself. So if I have to check the antenna, so this is where my Smith chart falls. So basically says if it's exactly somewhere near 1, so it will give me 1. So I need an output of 1 plus or minus J0. So no reactance at all, either capacitance or inductance. I want pure resistive, which is around 50 ohms. It's 1 because I have normalized it with the characteristic impedance 50 divided by 50 ohms. So 1. So this is how I can check here. Or if I want to straight away check only the S parameters, so anything below minus 10 dB, wherein my VSWR is approximately equal to 2 there. So if it could be, we can see this antenna is sensitive for 15 megahertz till 300 megahertz also. So antenna, whatever is designed, is operating at this frequency. Due to this radiations, whatever is occurring, if I have to check for, so when I go to results, I have a number of components here which I can select. So what is it that which interests us is the emission which is occurring at the cables at the EUT to the antenna. So when I check that, and when we see the results here, so all these S parameter reflections say that to the incident to the reflected wave, this is how it is happening. And if I have to check the conductance, yeah. So if we can animate it, select the structure, right click, and there is plot fields. So how exactly electric field, either in terms of magnitude or vector, or magnetic field in terms of magnitude or vector, or my surface current. If I have to check all these things, so we just have to select structure and take it. So if I have to animate this to understand how is the flow of it with respect to the phase, yeah. So I think we can see how the flow of it with the change in the power, which otherwise is affecting the antenna also. So this is how the antenna absorbs the radiation, and we can know how much is the electromagnetic interference which is occurring. So accordingly, we can now shield it, provide shielding or provide proper grounding, so that EMI is completely mitigated and we get a very good electromagnetic compatibility. So this is one such example here. So as such, either it could be for bulk conductivity or conduction emission. So if it is something which you are starting, so I would say go to open examples and look into all the examples which are already there, right from BCI to conduction emission to ESDs or radiation hazard. So everything could be analyzed, or you can take the components from the component library and have your own circuitry built up, along with putting all of them in a chamber atmosphere and properly check the shielding and grounding and simulate it to analyze the EMI EMC. Yeah. So these plots tell me the incidence and how exactly the reflections are occurring. Yeah, that was about the CISPAR 25 radiation emission circuit. So any doubt or anything to ask? We can have a discussion now. Dhanush, if possible, you can open one of our example there, and maybe whoever have installed the student version, at least if they want to try it, they can do it.
Yeah, I'll help it out them. Any doubts?
Outputs. So if I'm talking about radiation emission, I would look into my S parameters only. So how much is the signal being incident on the antenna and how much is it reflecting back? So that would easily tell me about the radiation emissions. So having these values, taking the values in CSV format or something, we can map it to how much is the radiation being emitted.
Okay, ma'am. Thank you. There is no doubt from any audience. Let's see. Any doubts? No doubts? Okay. 1 second. 1 second, ma'am.
Ma'am, hello. Can you hear me?
Yeah, I can hear you. Please tell me.
Ma'am, my doubt is that when you dial star hash 06 hash, you will get the star values for head and body. What does that mean? And how much distance should we keep the phone?
Okay. So according to my ITU and FCC standard, the SAR should be around 1.6 watts per kg, right? So if I have a 1 kg of mass of flesh or something, so 1.6 watts could be absorbed. So this is the standard which is given. So if we see AT&T network in US, so they are using the cellular communication at a much lesser power of what we are using. It could be for many reasons, population and everything. So here in India, we are exactly at that par of just below 1.6 watts per kg. So how do I, whatever value you have got, it's the standard. It will not go by any chance beyond that with respect to radiation. No chance at all. So even if your device get heated up, it could be for other reason of PCB and battery malfunction, but radiation with respect to your GSM communication or constant usage of your Wi-Fi or your 4G, the radiation will not be a problem. So if you want to check at what distance you need to keep, probably that would be, I mean, we always say keep it a feet away. So that's not something, it's a general idea which is told. So if you are using the cell phones, then again, as much as possible, so use wired headphones. Second suggestion, do not use Bluetooth speakers. Right now I am using that only, but then again there is a Wi-Fi, everything, the whole circuitry is placed inside that. So why do I want to use that if I can otherwise use it? There are a lot of small adjustments which we can do, wherein we can try to control this wireless scenario. Wired is always good for me. I mean, as long as my power is, I know where exactly the flow of whatever signal is there, and it is not there in wireless medium, I can do that. Lot of study is going on about finger movement also when I keep it near the ear, near my ears, right? So those things again I can do it in simulations. I missed to show you, there is even in component library a complete human phantom could be used. No, I'll just share the screen and show. So here when we see there is male and female complete human body exteriors, right from complete body to arm or to hand or leg or the torso or also could be used, wherein I can place my antenna beside it or the complete a cell phone package itself, and then place my antenna and understand how much is SAR. So if I have to check SAR, there is here local SAR and average SAR. So we can check that and find out in simulation.
Okay, ma'am.
Yeah, and one more question in the chat box, ma'am. Please check that.
Okay. I am not exactly sure about the values of CISPAR 25, sir. Maybe I will share you if it's needed. So whatever S parameters value I'm getting here in my results. So if I can convert that in, I mean, I can easily export that as a CSV file. And we have a certain equation for radiation emission and conducted emission, which meets the CISPAR values. So I'm not very sure with the values how much it is. If we can find out that those values are below it, so then it is adhered to those terms. So in simulation, what we can do is whatever shielding we give, we can try with different materials. So these materials, and check its corresponding S parameters and radiation emission. So that will be a very good study for us to understand each shielding, how I can give, so that I can protect right from a small device to a complete aircraft or a ship itself. Those things could be played around.
Okay, anybody else? Any questions?
So I have this feedback.
Mike.
Hello, ma'am.
Yeah.
Yes,
sir.
I have a question. Earlier you said that there were many crashes for helicopters due to when they came near the broadcasting tower. So how exactly is the shielding done for these circuits that is present in this?
Shielding, right from, if there were a lot of electromagnetic absorbing or reflecting paints itself. So it started from that. From there to, it has evolved in using some metamaterial surfaces. Sometimes what happens was the shape of these aircrafts or ships, which is designed in such a way that the radiations are not absorbed at that frequencies, particular frequencies. So usually this is used in radar cross sections and all. Or nowadays different kind of materials and different kind of structures are used, especially with metamaterials. Lot of shielding applications for EMI, EMC is coming up with metamaterials and RIS, reconfigurable intelligent surfaces.
Okay, thank you, ma'am. Thank you, ma'am. It is time to express our sincere gratitude to our esteemed guests for gracing the occasion. Now I would like to welcome Dr. Deepti Das Krishna, HOD, Department of Electronics, to deliver the vote of thanks.
Dhanush and Swetha for agreeing to our request and for coming forward. In spite of her bad health, Dr. Swetha had spent almost 2 hours explaining. I think we should give a round of applause to Dr. Swetha and Dr. Dhanush for coming here on short notice. I hope we'll have more such interactions, and hopefully next time Dr. Swetha could come here personally. We are having a course on EMI, EMC in the next coming semester for the MTech students. So I hope these sessions are helpful to most of the students who are present here. So as a token of our appreciation, I would like to hand over a memento to Dhanush to take back to Bangalore.
Thank you, ma'am. Thank you so much. Thank you for understanding. I'm so sorry I couldn't be there today. I'll definitely plan for it in the coming months.